Hello everyone. Today we will discuss about the powder metallurgy. Powder metallurgy is a metallic process or the processing technology in which the parts are produced by the metallic powder. The main advantage of the powder metallurgy process is the production of the component net to the nearest shape of the component and the subsequent machinings or the machining process they can be eliminated. Next topic is the conventional powder metallurgical process. The powder metallurgical process depends upon the type of the powder what it has been used. Either it may be a pure metals or it may be a alloy powder. Whatever may be the material, the process it remains same. Only a slight changes in the process. The first step is the compacting of the mixture in a die and then sintering or heating the resultant shape in the atmospheric control in a furnace to the metallurgical to bonding the particles, and then if the machining is required, even that can also be processed. The schematic diagram shows the how the powder metallurgical process or the how the powder metallurgical components are fabricated. The first basic thing is to get the metallic powder. Either it may be a metallic powder or it may be a alloy powder. These powders are compacted or pressed in a press, and then afterwards the obtained compacted net near shape component is heated in a oven. That process is nothing but a sintering process. This sintering process it depends upon the type of the material what we are using it. The sintering it can be done even in the furnace also. Certain materials are very difficult to fabricate by using the normal conventional method. In such cases, powder metallurgical techniques are adopted. The best example is for this method is nothing but the tungsten filament. The powder metallurgy is used for the manufacturing the product or the articles from the metallic powder. By placing these powders in a mold and are compacting to the required shape. The typical examples of such products are the grinding wheel, filament wires, magnets, tungsten carbide cutting tools. Most of the applications are even in the cutting tools, and some of the other applications where it is very difficult to fabricate is the turbine blades, which are having a high temperature strength. The manufacture of the parts by the powder metallurgy process involves a manufacturing of the powder, blending, compacting, sintering, and number of secondary operations are required to get the required component. The compressed article or the compressed component is then heated in a oven or a furnace much below the melting point to bind the particles together and to improve their strength. The non-metallic material can also be added to the metallic powder to provide an adequate bond or imparting some mechanical properties which are essential for the component. The product made through this process are very costly. The powder is almost of all metals or a large quantity of alloys and non-metallic materials are also used. The application of powder metallurgy process is economical feasible only for the mass production. The parts made by the powder metallurgical process exhibits a different properties which cannot be produced by the conventional method. Next topic what we are discussing is the powder production techniques. Even in this powder production techniques, there are three different types of techniques which are available. The first one is a mechanical method, the second one is a chemical method, and the third one is a physical method. The first topic what we are discussing is the mechanical method of powder production. In that, the chopping or cutting, the abrasion methods, machining methods, milling methods, and cold stream process. In the chemical method of powder production, reduction by oxidation or reduction of oxides, precipitation from solutions, thermal decomposition of compounds, hybrid decomposition, thermit reactions, electrochemical methods. In the physical method of the powder production, water atomization, gas atomization, and special atomization method. In this slide, we will discuss more about the mechanical methods of the powder production. Chopping or cutting. In this process, the strands of hard steel wires of smaller diameter is cut into a small pieces by means of a milling cutter. The powders which are obtained in this process will not have a definite size or the shapes. The major limitation of this is it is very difficult and costly to make the powder by this method. For this reason, it is not profitable for discussing the mechanical method of powder production. Rubbing and abrasion method. This is one of the method which can be used by which the addition of other material takes place, by which the contamination is maximum. Rubbing. When we rub two surfaces against each other, the hard surface and as well as the soft surface converts into a powder. Along with the soft material, some cases or some particles of hard material also includes into that, and the contamination takes place. Filing. Filing is a production of method in which the powder can be obtained very easily, and in this method alloy powders can be obtained very easily. Even in this also the contamination is a major problem. These methods are also used for the manufacturing of coarse powder of dental alloys. Scratching. Scratching is one of the method in which the hard pin is rubbed on a soft metal. The powdered flakes are produced. Scratching is a technique actually used for the larger scale preparation of the coarse magnesium powder. Machining. The machining process is also one of the method in the mechanical powder production. The examples are the lathe and as well as the milling machines can be used for the powder production. The lathe machine, by applying a small force, you will get a finer chips. A large amount of the machining scrap is produced in the machining operation itself. This scrap can also be used for the further applications. The disadvantage in this technique is the lack of control on the powder characteristics, includes the chemical contamination, oxidations, oil inclusions, and other metal impurities. The shape of the powders are irregular and coarse. The another advantages of these techniques are for consuming the scrap from other process. Machining is useful for the further design of the component. Presently, the machined powder is used with a high carbon steel and some dental amalgam powder. Ball milling. Ball milling is one of the oldest and highly adapted technology for the alloy components. Ball milling is the only method in which a relatively simple when compared to the other process. In this method of grinding, a large lump of material can be converted into a small pieces by the impact of the ball. The principle of this process. The principle is simple as it is based on the impact and shear force. Hard balls are used for the mechanical commutation of the brittle material and producing the powder. Milling unit. The basic apparatus consists of a ball mill or a jar mill, which mainly consists of a rotating drum inside a hard material, which is nothing but a ball. The hard balls as a grinding medium which continues to impact on the material inside the drum when the drum rotates at higher speeds. The important parameters. The most important parameters to be considered is the speed of the rotation of the drum. An optimum speed control is adjusted for the maximum impact velocity. The critical speed is the speed above which the ball will centrifuge. A very slow speed of rotation will not carry the ball to the top. This will roll back or rolls down the drum sides. Very fast or the high speeds will not let the ball to drop down, as they will be carried around the drum due to the centrifugal force. Thus, the optimum speed is essential for the ball milling. This speed of rotation varies with the inverse square root of the drum diameter, the material of the grinding media and its size and density. The size and density of the milling medium is selected according to the deformation and the fracture resistance of the material, that too especially the metals or the alloys. The size and density depends upon the type of the material what we are using it. For the hard and brittle material, large and dense media is used, whereas the small balls are used for finer grinding. As a general rule, the ball should be a small and their surface should be a very little rough. The material of the ball and the lining of the drum should be same as that of the material being grounded. The rate of the milling of the powder is a function of quantity of the total space between the balls. The lubricants and the surface active agents are used to nullify the welding force which causes agglomeration. The schematic diagram shows the ball milling. The ball milling consists of a drum. A drum is supported by two rollers. These two rollers rotates the entire drum, in which the drum consists of the balls along with the metal powders which has to be crushed to get a metal powder. The next process is nothing but the grinding mechanism. During the milling, the following process are the forces causes the fracture of the material into powder. Impact force. These are the cause by the instantaneous striking of one object on the another. Shear force. These are caused as a material slides or rubs against one another. The limitation of this mechanism is the rubbing action causes a contamination of the metallic powder, and also the ball may also get rubbed. The working a hardening of the metal powder causes during the milling. There is a possibility of excessive oxidation of the final powder. The quality of the powder is poor. Practical welding and agglomeration may take place in this process.